Hello guys, good morning. Welcome to another episode of Ksan Talk Show. We are going to code Advent of Code 2025. Day 1, Problem 2 in Wolfram Language. Video check, audio check. Okay, so I'm using Ultimate Hacking Keyboard UHK80. That's this one. Fantastic. I got a review on YouTube. You can watch. Okay, so today's talk show continue from yesterday. We did day 1 yesterday. So it's fantastic video check. So if you are watching this offline, play at 1.5 speed. If you are watching here live, say hi. Hello, Dan V. Hello, everyone. So, Dan V, are you a Wolfram Language coder? Are you already know Wolfram Language, or are you Emacs Lisp Emacs user or Python coder or something? So let's begin. Okay, so we did yesterday Wolfram Language. This is yesterday. So the problem, we drew a diagram, interesting diagram, advent of a code. Usually you have to do diagrams. Okay, so and today part two, problem 2. Okay, now if you don't know Wolfram Language, it's the most advanced high-level language by a magnitude, more than Haskell, Julia, Lisp, Clojure, any Lisp, any fancy language. Okay, and you can download it here. Follow this link. Search for Wolfram, download Wolfram engine on xali.info. Wolfram language for programmers. Okay, you can download it for free, beginning about 5 years ago. And go back, download, and Wolfram language for programmers, and the XA Wolfram mode, which I'm using, allows me to code Wolfram language in Emacs. Okay, let's begin. Okay, and XAFly keys, that's my key binding system, most efficient, even more efficient than Vim or NeoVim, if you count keystrokes for Emacs. Okay, so I've done like hundreds videos about all those topics. So today let's focus on the day 1 part 2. Okay, so go to the problem, go to it, switch to it. That's the right answer. You are 1 gold star closer to decorating the North Pole. Continue to part 2, the problem part 2. Let's read it aloud like reading a poetry day. I still have code. It's annoying. I still have code. Okay, this you see this advent of code, idiotic website design. They have hard-coded layout, so you cannot have narrower window. Very idiotic. Okay, let's just continue. Okay, so comments, if you have comments or questions. Hello, light something. Hello, Danby. A little bit of Wolfram, not so much Lisp, but interested. Fantastic. Okay, so I'm starting to grow audience of Wolfram language. Before it was keyboards and Emacs Lisp and stuff. So part 2. Okay, so let me have a sip. I'm still having a cold. Okay, so you are sure that's the right password, but the door won't open. Okay, so you still need to increase this. You are sure that's a password, but the door won't open. You knock, but nobody answers. You build a snowman while you think. As you are rolling the snowballs for your snowman, you find another security document that must have fallen into the snow. Due to newer security protocols, please use password method 0x434C49434B until further notice. Okay, so it's got the document, okay, with that magic number. Okay, you remember from the training seminar that method, this, now check, is that the same number? Yes, it is. Okay, now method, this 0x something, means you are actually supposed to count the number of times any click causes the dial to point at 0. Okay, regardless of whether it happens during a rotation or at the end of one. Oh, you idiotic fuck. I think I already know what's the problem. So previously, you want to count after each rotation, left or right, if the pointer is at 0. Okay, but now, I suppose you want to count every time if it passes 0. Okay, I suppose that's what the question is. Okay, so method that means you actually supposed to count the number of times any click causes the dial to point at 0, regardless whether it happened during a rotation or at the end of one. Okay, so if you just count when it stops at 0, then that method is given a name, this 0x something. Following the same rotation as in the above example, the dial points at 0 a few extra times during its rotation. What does that mean? The dial starts at pointing at 50. The dial is rotated L68 to point at 82. So 50, L means minus, 50 minus 68 is negative 18. Then because there are 100 numbers, you plus 100. So 18, negative 18 plus 100 is 82, okay? Check. So point at 82. During this rotation, it points at 0 once. Okay, now you need to go back to the diagram. Okay, let's see. So when you have a diagram like this one, so it basically certain rotations, the pointer will pass 0, or 0 will fly by it. Okay, so what are you saying? During this rotation, it points at 0 once. You see, a bit ambiguity, because now you don't consider rotation as one shot. I mean, so each click, it stops. Click, 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 stop, stop, stop. So during this rotation, it points at 0 once, okay? The dial is rotated L30 to point at 52. So 82, L30 minus 30 is 52, okay? The dial is rotated, then R48 to point at 0. So R48 plus 52, that's 100, plus 100 divided by 100 is 1, minus 1 is 0, okay? The dial is rotated L5, then you got 95. The dial is rotated R60 to point at 55. During this rotation, it points at 0 once. Okay, and blah blah, and blah blah, and blah blah. Okay, and blah blah. Dial rotated L82 to point at 32. During this rotation, it points at 0 once. Okay. In this example, the dial points at 0 3 times at the end of a rotation, plus 3 more times during a rotation. Okay? So, in this example, the new password would be 6. Okay, be careful. If the dial were pointing at 50, a single rotation like R1000 would cause the dial to point at 0 10 times before returning back to 50. Okay, so it's becoming tricky. It's gonna tell you to overturn, R1000. So using password method, what is a password to open the door? So wait a minute. So this password method, okay, this method basically tells you to count anytime when 0 is passed. Okay. Okay, so now I know the problem, and I can, so we need to start to code, starting to become boring or interesting, depending on your point of view. Nobody's here, no comments? Okay. Did I read the problem correctly? Okay, let's begin to code it. Okay, so what is the, okay, start the code. Wolfram Language, and we pop it out, and we probably, so let's look at yesterday's code. So yesterday we basically modeled the log, the rotational log, just a list of numbers. So we need to think about this. Okay, so when you rotate, God, I still got cold. Shit, I got cough. So you need to rotate. So yesterday we thought about modular arithmetics, which can compute what is the ending number. Okay, but now you want to compute the past zero. So very easy. So now, first of all, if it gives a number, huge number, that's over 1,000, so any number more than 100, you can just modular arithmetic it. Then you get a number is cycles. So for example, 1,000 divided by 100 is 10. That means this cycle will pass 0 10 times. Okay. So you see, so any number when it's greater than 100, you can just do a mod, and the resulting number just add to it. Okay. But then other than that, let's see. So if let's say you have something like that, you want to, so how do you determine when 0 passes? Okay. So let's say the current number is 5, and you rotate right by 1, you get 6, you don't pass 0. Okay. Now if you rotate right by 2, you get 7, you don't pass 0. Okay. Now but if you rotate left by 1, you get 4, no passing 0. So when you rotate, let's see, 1 2 3 4 5, if you rotate left 5 times, you stop at 0. Okay. If you rotate left 6 times, you pass 0. Okay. Now, is there a distinction between stopping at 0 and passing 0? So in other words, does stopping at 0 count? Tricky question. This elves shit trying to trick me. So when you stop at 0, does that count as like 1? Oh, yes, it does, because, it like stopping at 0. In this example, the dial point is 0 3 times at the end of the rotation, plus 3 more times during a rotation. Okay, so you count when it stops at 0. You also count when it passes 0. So both of them count. Okay. So now when you stop at 0, so when you pass 0, so how do you know when it passes 0? When the number of rotation is, let's see, okay, this is about greater than or equal or less than problem. So if you are rotating left, and the rotation number oh God, what a tedious problem. Okay, so I need to suppress my cough. So you need to count the total number of 0, including passing 0. Okay, let me just think about this. Okay, so have you guys done the problem? No comments? Okay. So when you rotate left, first of all, the number are arranged in counterclockwise. Remember that. Now, when you rotate left, and when the number of rotation is greater than the current number, so the current number is 5. So if you rotate 5 to the left, oh, okay, so there's a left and right issue. So if you rotate to the left 5 times, 5 is equal to the current index. That means it ends at 0, because 5, rotate left minus 5 means minus 5. You get 0, okay? But if you rotate left 6 times, that's 5 minus 6, which gets you 99. Okay, so you pass 0. So how do you, so if the rotation number is greater than the current number, okay, then you get okay, we can simplify this by modular arithmetics. Let's write it out, because I'm doing a live stream, so let me just, keep myself busy so you can see what we're doing. If the current log number is the current number, let's call it current index. Wide speed asparagus. What does that mean? Wide speed asparagus. The current number, let's call it current index. The rotation number is number of clicks to rotate. Oh my god, cough. For example, R5 it's 5, okay. So you got the current number, you got the rotation number. Let's call it C. Let's name it R, okay. Let's make it. Let's not use N. N is 5, okay. So, we start to name variables. If C what Oh God. Okay, let's copy it. Let's do it in Wolfram language. Okay. If n is greater than c, Zizo is one odd thing. Oh God, I got this cough. So if n is greater than so you got rotate left and rotate right. You got the left and right issue. So first of all, mod n 100. Okay. Then let's say total. Number of times passing 0 or including stopping at 0. Okay. So total equals to first of all, okay, so it's starting to make sense. C equals to something, okay? C equals to current number, let's say 5. Okay, then the rotation number, let's say given R5, n equals to 6. Okay, let's say 6. Okay, now it's all simplified, you see. Now given let's say 600. First of all, total equals to modular arithmetic 1000 over 100. Do it. Let's see what happens. Running Wolfram language. Oh, wait a minute. You want that's a remainder, so you can do mod. You gotta use the dividend. Let's see. Dividend, divisor, quotient. You wanna get a quotient, okay? Not the remainder. So let's see if there's a function named quotient. There it is. So what is the syntax? I don't know. Let's just trial and error. That's correct. Looks like. So let's look up the documentation. Quotient. Oops. Oh, 1000. No. Quotient. Quotient mn gives the integer quotient of m and n. Fantastic. Okay. Now Wolfram language got fancy stuff. Quotient table, something. Okay. Quotient is what we want. So first of all, total equals to quotient n. Okay. So first of all, you do that. Now you need to take care of which way it turns. So because the result is different. Okay. So So if current number is 5, let's go back to our diagram so it's easy to understand. So current number is 5. If we rotate to the left, okay, let's change this to left for now, okay. Rotate by 6. Okay. Rotate by 6. So we will end up at 99. So let's just first of all document it first. Okay. New C equals to mod. I'm pretty sure. So current, so C and N. Okay. So we run it. Okay, so this gives you 5. Wait. That's what? Oh yeah, so mod, wait, so that's right. So C plus N mod 100. Okay. The result should be 99. Okay. And actually minus 1. We need to minus 1. Okay, let's try it. Wait, not plus. Okay, this is minus. Remember, L is for minus. Run it again. Fantastic, but not quite correct. That's off by 1 issue. Let's double check. So if we want to rotate left 6 times, so 1, 2, 3, 4, 5, 6. So 6 times, it should result in 99. So you don't want, wait. You don't want minus 1. Yeah. But if you don't minus 1, there's a problem. Okay, I think. Wait. So do we want the modular to be 100 or 99? If it's 100, the remainder is always between 0 or 99. That's right. So if the modular number is, let's say, 3, like something divided by 3, the remainder will always be 0 or 1 or 2. That's right. So always one number less. So if the modular number is 100, the remainder is always between 0 or 99. That's right. Okay. So the current index 5 minus the rotation L6. This actually, let's code the minus sign into it. So this is cleaner. Okay. So L means minus. Okay. Yeah. Then okay, let's run it. Okay, it's 5. What are we doing here? 5 negative 6. Run it. And what about this part? This part, this is the quotient. So if it's negative, we don't care. Only if we want to do this only when, oh God, when n is greater than 100. So ignore this part for now, okay? But now is this part right? So okay, so let's remove that. Let's move it down. Okay. So I hope you are feeling better. Okay, I'm doing better. Okay, so now so let's just model this one single rotation. Did we get it right? The current index plus rotation and modular arithmetic 100. Okay, so hold on a second. So you want to get the remainder and modular arithmetic. You want to get the quotient and the remainder at the same time, one shot. Let's see. Let's see if there's a function does that. So mod gets you the remainder modular operation. Okay. Now, is there a function that combines both mod and remainder? Let's see. Quotient remainder. There it is. Let's open a new tab. Give a list of the quotient and remainder. Fantastic. Okay. Okay, let's test. Let's say 10, 20 divided by 3. Okay, divided by 3. 7、7、3、5、15、36、18. So you got 18. 3 times 6 is 18. Remainder is 2. That's correct. Okay, now let's modify. Okay, let's modify this line. Okay, so we don't want mode. So okay, so let's put there and something like that. Okay, and this we don't need. Let's run it. Okay, so the result is this is 99. That's a current index, and this is the new what does this get you? So let's see. Okay, so the result is that, and what does that signify? That means C plus N. What? Oh, it's negative. It's a negative number. Okay, now you need to deal with negative number, you see. So 5 minus 6, what? So basically we are doing this thing. That's right. Okay, so this number on the left, this quotient, integer quotient, the absolute value of that means the number of times it has passed 0. I tell you guys, okay? So we already got this figured out. Now let's say if the number is 5, rotate from the left 5. Let's see what we get, okay? So let's remove that. Okay, run it. 0, 0. Okay, so the left number, the left-hand side, the left number means the number of times it has passed 0. Now the right hand side, the second number is the new index, and if it's 0, we have to add it. Okay, so now it's so simple. Now let's just experiment. What if we are rotating right? So, excuse me. Oh God, this. So negative. Right, let's look at the diagram. So if we rotate from the right, so let's say rotate 5 from the right, what you get? You got rotate right, so 5, 6, 1, 3, 4, 5. So you got 10. Rotate to the right, and you pass 0 0 times, correct? Yes. So basically this formula is correct. Okay, we can kind of let's write a function. Okay, let's just doodle, because I keep coding, keep busy. That's the key to live stream. So function current number. Okay, then rotate. Okay, let's say rotate n. Okay, current number, we are writing a function equals to basically just copy the whole thing here. So so you can just do a block. Block is like a local variable. Okay, expressions here, and we don't need local variables. So the current number is the C is a current number. Okay, so C is a current number. Dun 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 dun. And rotate n is the n. Okay. And what is this new? Yeah, remove that. Why do you need? Oh yeah, so we don't need that. That's the second. That's already here. Delete that. So delete that. So one single line. So it's actually just one single line. So, and in fact, it's one single line. You don't even need that. So that's our function. Okay. This function will. Wait, this is not. We have to say. X operation. Okay, this is our rotation. This is our function name. Okay, so here, this is our function. This function takes two numbers, the current index, then rotate n. Rotate n is a positive or negative number. Okay, and it returns. We can start to document it. Let's go elaborate. Okay, this is how you document, how you do inline documentation for Wolfram language, like this. Okay, so you just say returns a list a, b. A is, let's say CD. Okay, C is the number of times it passed 0. D is the new number, the new index number, let's say. Okay, so it's all clear. So okay, so this all clear. Now let's try our operation. Let's run it. Operation. What do you wanna say? So you wanna say 5, 5, 5. Run it. Okay, so let's put a semicolon here to suppress the output to make it return null. So when it returns null, there's no output. So run it again. So you can see it now returns this 0, 10. It's repeated because we got the examples here. So in fact we don't, yeah. So anyway, it returns 0, 10. Okay, now, okay, so hold on a second. Let's clean up. So let's cut. Let's move these out. Okay, so Wolfram Language, this is our model. And now we got the function. Okay, so, and what about this part? Okay, clean. Now run it. So here is the output. Now 5, -5 means rotate left. Okay. Okay. Now if you say 5 negative, six. I'm going too slow. I'm going too super slow. So anyway, so this, yeah, you rotate left 6 times. You will go over 0 1 time from this side, from the left rotation side. So it actually tells you which side you went over 0. So, but if you do this, let's say 60 times, you need to go over 600. Okay, so let's see. You will end up in 99, but passing it 11 times, I think. Wait, actually, no. That's right. So you'll pass 0 6 times and ends up in 5. Wait, is that, so what if you do 100 times? Can we like put a print statement somewhere here? Let's do a print statement. Okay, print. What do you want to print? You want to say because this is beginners Emacs tutorial. There's one I did about 2 or 3 years ago on YouTube. It's got a few thousand views. But, so do you know about that? But maybe I should do a new one though, because it was a few years ago. So anyways, let's focus on this, okay? We almost done. We just need to what are we doing? So the current number is 5. You rotate left. So it's just come on. Let's get this to work, man. So yeah, you rotate 100. You rotate left 100. You go back to 5, but you got that 1 there. So if you rotate left 600, you get back to 5, but you got 6 times, okay? Now, what does the right, if you rotate right, let's see what happens, okay? A minute. Okay, so I think I know the answer now, okay? So the final answer is you need to, so you got this function operation. So you are given okay, so let's put it back. Syntax correct, showing browser, regroup. So we got a beginning model, then we wrote a function about it, and we tested, seems to check out. And now, so the problem is that we're gonna be given a bunch of these L right. So we do as before. Can we do as before? Let's see. We do a yeah. So before we are using actual model of the, we got a list of 50 to 0 to 99. We shift the list, rotate left and rotate right. So we actually model the log almost physically. But now what we are doing is modular arithmetics. So we don't need to keep the huge list. So in the beginning state, it's going to be, yeah, so let's copy the code, okay? Let's copy the code. Let's start to code today's thing. Excuse me. Almost done. Almost. We are applying the technique of one-shot coding, where you think for 1 hour and you press a button and it's all done. One shot, correct? Okay. So this is the input. The beginning input is going to be 0 and 50 because the current index number is 50. Okay. This is init state. Okay. Then the input is this bunch of thing. Okay. Let's clean it up. Then the result, same like before. Let's see, init state, let's color it. So then the input, let's color it. Okay, pink. Then we need our function. Copy this operation. We define the function here. Operation, okay. Okay, so there is our function. Let's make it one line, and this test we don't need. Test. Okay, now our operation. So now you can see we do a fold list. If you guys don't know what's a fold list, that's same as reduce. And here is a illustration what it does. Okay, just like reduce in Python and JavaScript. Okay, so you do a fold. In fact, fold or fold list. Let's see. Anyway, so you got a fold. Fold takes three things. One is the function, which is here. The second argument is initial state. The third argument is a list of input. This L R L R. Okay, now we need to change what function we feed it. Now the function will take two arguments. Okay, so this z list, let's call it state. Okay, now and the X operation. Okay, and did we, okay, we don't want to confuse the names, so this so let's rename. So this X operation, let's name it do operation. Okay, let's just say compute. Let's get an elaborate long name. Compute rotate. Let's say compute rotate. Okay, let's just say do rotate. Okay, so the function takes two arguments, a state and the do rotate. And now, before we do something else, let's do a little trick. Let's change this L to negative and R to positive. So we don't have to do the string processing, the string start in, the annoying, like cheat, because advanced code, they don't care, they don't care how you get the answer. So let's not have some artificial restriction, like supposing the input is such. Let's just so what do you do? Call XOR quote lines. No, XOR replace brackets, replace quotation mark by none. Okay, now do find replace again. Replace capital L by negative. Okay, then replace capital R by positive. Actually, just remove it. Okay, so our new input is just that. Okay, save it, close it. Save it, close it, reopen it. So we get rid of the syntax highlight. Okay, so it's just that. Okay, so now you don't have to do the state. If something, if. So this if statement, in fact, because we are not doing any of that, we are not doing the rotation. So, okay. So fold, wait, what is our fold? Okay, now it becomes this simple. Now, the function, two arguments, state and do rotate. So what? So it will happen. Yeah, that's right. So it will give you a list. So in fact, this whole function is simply to rotate. Okay, you don't need even to define a personal function. So the whole thing is just that. To rotate is a function that takes two arguments. Then we got initial state, we got input, then this count. Let's not do it yet. Let's compute this and see what we get. Okay, copy all. Now start Wolfram Language, the most advanced, superior, supreme language. Start it. New notebook. 3, Shift Enter to start the kernel. Okay, and make it 150 huge. Okay, now pray to God this will work in one shot. The result should be, we have to do one more step, okay, but the final answer should be 6. Paste. Okay, so you can see, right. So Shift Enter. Fantastic. Okay, so here is a result. Let's expand. Show all. Okay, so here is the result. Let's see, each time what does it you see the answer is pretty long, but maybe I don't need fold list, I just need to fold. Let's just see. Shift Enter. Okay, I think something is not right. Found it, thanks, but still looking forward to your new video. Thank you. So yeah, maybe I should do a new one. The old one is still good, you know. It's like YouTubers, like every few years, you know, you want to do a fresh one. But it's the same. I mean, the content, even at least haven't changed that much. So, but if I do a new one, I probably would improve it because now I have more experience doing live YouTube. Anyway, this problem is like I have a headache. I'm now solving this, which is no good. It's already 1 hour, and I need to cough so badly. Okay, you need to think. Okay, do you guys understand what we're doing? It's not super clear. So this function, every time it returns two list of two numbers. Okay, that's wrong. So what do you want to do? You want to make this number, this function takes a number like that. Okay, so let me show you. Okay, you want it to, because that represents the state. Yeah, so pass 0 count. Okay, you want this function to take a number like that. So that is the current state, past zero count the previous state, then the current index number, then rotate. Okay, so you can either change this function or you add this little bit over here, so you create a new function. Let's create a new function. Okay, let's just do whatever comes to mind for now. Okay, function. So this function takes 2 arguments. Okay, state and new ops. Then in the function you will need to call do rotate. Okay, so so in fact the state God, anyone is watching, because right now I feel like aborting. 6 people. 6 people is not too bad, because I got cough and I need a break. My back hurts. Do I look good? Not too bad. Not too bad for my age. Okay. So what we doing? We want to, so the function right now, this line takes the current number and the number of rotation, then it returns a pair of numbers. Okay, then you want to return some pairs of numbers. It's kind of embarrassing, because otherwise if you do in Python or other people, you finish it in 10 minutes. God. So anyway, so the function right now returns these pairs, a list of 2 things, and then if you make it, you want to know the total number of times it passes 0 or ends at 0. So compute. So so why don't we make the function take an argument like that? It'll be easier. So it will return previous past 0 count, so you need to modify this because you need to add the previous 0 count. So you can either do it in this function or not do it in the function, or if you just do it like that. Okay, so questions, decisions. Jesus. If you accumulate in the function, then you don't need fold list. You just use fold. But if you don't accumulate, then you need fold list. Then you need to, at the end, count all the zeros and the number of times passing 0. So, but you have to think. So let's see. Each time so this is very simple. Current number, initial state, input. So why don't we just make it no, you have to Right, so number of times passing 0. Is this interesting? Okay, we can do this. We need to finish this number of times. So this function current number take. So if we were to write it this way, then what will it return? It will return let me just like start to code it. Okay, so that then you so the problem is when it stops at 0, God. So this -1 must be absolute. You need to make it absolute value. Okay, let me just code it quickly. Okay, so it's going to return a pair of numbers, and this is gonna be absolute value of that plus that plus if the remainder is 0. If remainder equals to 0, then 1, else 0. And the second number is the this is the remainder. Okay, something like that. Okay, if we do that, then we need to modify the new usage. Oh god. Yeah, but I just want Okay, so we need to modify this. Do you guys see what I'm doing? Do you guys understand? Maybe not. Let's forget about the documentation for now. Okay, let's just run it, see if I can get it to work. Something like that. Okay, then you don't need so turn 6. If it does, then that means we are done without thinking too much. No, it returns 9. 932. Okay. Not right. What's our initial state? What is the initial state? Any state 050. Okay, so see 050, then 1 1 3 4 5 6 7 8 9. So every time it adds 1. Oh wait, yeah, we got this wrong. So this remainder, if what? If remainder equals to 0, then that means it stops at 0. Okay. So let's see the advent of code. It says something something 50 82 52 50 82 52. We got the numbers right. Then 95 55, then 0 95 55, then 0 99 0 14 32, 0 99 0 14 32. So we got the rotation right, but it just the counting is off. How is the counting off? Well, because quotient and remainder. Am I doing good? Are you guys like still watching? Does it make sense? Need to finish this. Yes. So current so we got the counting of the passing 0 incorrect. So let's see. 0 0 some trivial error. So absolute quotient. So now let's double check. So if this operation, that seems right though. I don't know. So let's go back to previous. So operation 90. It should be 0 on the first part. That's right, 0. So if it's 99, then it's let's rotate right. Then it's 1. That's right. So this seems correct. Okay, so but what is not correct though? So the C, its quotient remainder past, that's the previous past 0 count. What is the initial state? Initial state is 0, 50. Okay, initial state is 0, 50. Okay, and quotient remainder, yeah, I don't know. We need to debug this. So 82, then it's 1. That's correct. Then when it's 52, rotate L30. Then you got 52. So the quotient is still 1. I mean, the number of times it passed 0 is still 1. So far, so good. Then R48, you got 0 again, okay? Then you got 0 again, and all of a sudden you got 3 here. So this step is incorrect. So then you got 3 again. So how we get 3? Because we got 1, so it added 2. Right, how to say 52? So when we get 52, then R48 0. So that's 1. That's 2. Shouldn't be 3. 1, 2, 3, 4, 5, 6. 6. Our logic is incorrect somewhere in this very simple line here. Okay, this line somewhere. So this past 0 count should be named previous. So that makes it easier to see. So quotient plus previous. Now, if you don't add this remainder, what happens? Maybe they'll get it right. Okay, you know, just do it. Probably right. So you got 632. Now we happen to, because we are brainless, so we do trial and error, and we are correct. But now the step is to figure out logically why is it so. I don't know. I mean, it's like you just have to think about it a little bit. Okay, so let's put this back and let's try it on the real problem. Okay, so let's just try the real puzzle input because I got pretty tired of it. So the previous puzzle input is this one, big number, copy. Okay, so paste it, make a copy, paste it. Now replace or quote symbol by none. Do it. And replace capital R by none. Do it. And replace capital L by negative. Do it. Okay, we got a big number. Now make them multiple lines. Okay, instead of one big line because Emacs has problem. Okay, now cut, close. Actually, let me open it. New. Okay, copy, close, close. Now go back here. Now this is new input. Okay. Now make sure. Delete that. Wait, delete that. Okay, that's a new input. Now let's solve the problem. Now we are done. Okay. I beat ya. Copy. Go to Wolfram Notebook. Select all. Paste. Do it. 6583. Am I correct? Let's just submit. Paste. Submit. That's not the right answer. Fuck. Go fuck yourself. It's not the right answer. What? Okay, so what is not the right answer? What are all these numbers? Okay, these numbers are big input. Now, did we, let's see, input. Okay. Now we don't know. Suppress the input. Okay, so this usage is outdated. Okay, and wait, why are we doubling it? Shit, idiotic. Okay, so but why is it not correct? This usage is incorrect, but okay, but it just returned a number, right? At the end. Wait, what is this? Fold to state, init state. Did we get init state right? I think so. Init state 050, right? So let's just do it again, okay? Select all, paste, shift enter. 6580. Not the right answer. Your answer is too high. If you are stuck, make sure you are using the full input data. Stupid input data. Did we actually get the input? Wait, did we get the left and right correct? Like, did we, right is positive, left is negative. So let's look at our, so begin right 10, left 11. Wait, begin right 20, right 10, left 11. So 20, 20, 11, that seems right. Okay, check the last part. 22, 34, 36, negative, positive. Okay, 22, 34, 36. Okay, negative, positive. Okay, is the data incorrect? The data seems to be correct. And so all these rotation. Now, is there a rotation of 0? You tricky fuck. No, you know, we haven't checked the rotation of 0. It should also work though. So every time it passes 0, it counts, right? So why is it I don't know. So if we do fold least, let's see. Let's show all intermediate result. Okay, so you got this huge show all. So beginning 0, 0, 0, 0 doesn't pass, then 1 started to have more accumulated, 3, 4, 5, 12, 14. Okay, then 1000. Okay, one problem with this state output is that it doesn't show what's the input, because if you can also see what is the input, such as this 569 big number, that must pass at least 5 times. So then it's easier to debug. But now you got this output, so it just increases. That's right, because it always increases. Is there any anomaly? I don't know. So if you look at the right side, that's a current index. So for example, here 4117 0 it should have been added, but it's not. Okay, so I think, you see, previously it magically worked. That's incorrect. We just happened to work for that. We should have not just removed the reminder. Do you guys know what I mean? Like if we put it back, and you see previously we got this, I already removed it. Okay, but you should have, I mean, the issue is what happens when it stops on 0. Okay, so the question is what happens when it stops on 0? Okay, yeah, we need, let's see, where are we? So we need to check what happens. You see, here is the problem. So previous, let's try to rewrite this. Previous first plus absolute quotient, previous 0 count. So if it stops on 0, like what we had, is that if the remainder is a remainder. Yeah, if the remainder equals to 0, then you need to add 1. Otherwise, add 0. Something like that. Okay. So I don't know why is this logic incorrect. You see, you need to, if you do this, then okay, so let's look at our code. So we got that okay, then we got that. So let's modify the documentation so it's better. Okay, yeah, it's repeated. Yeah, so let's make a good job. Let's do a good job. Documentation, the previous implementation is that, remove that, but now we got that. Okay, so this is a new documentation. Previous 0 count, current number, rotate in. Okay. Okay, and the returns, what does it return? It returns a new that. Where the new includes if current index number is 0. Okay, something like that. Okay, this is the correct documentation for this code. Now, but the issue is this little part that, so if stops at 0, so let's say 5. Let's go back to, we need to sit down. We can't rush, even we spend an hour. Other people finish this in 1 minute. There's a lot of people, these speed coders, They finish the problem in 1 minute, in actually a few seconds. But we need to solve this, so we need to sit down and think about this. Where are we? So we need to go to, let's look at the diagram again from yesterday. So this diagram. So if the current number is 5 and it rotates left 5, so 1, 2, 3, 4, 5, then it ends up as 0. Then that 0 should be added because it stopped at 0, okay? So, right, so that's why if the remainder is 0, you add 1 to the count. No, but does that create consequences, accumulated consequence? So if it's at 0, you guys comments, okay? So if it's at 0, oh wait, it's either or. Wait, okay, so the absolute quotient, it's either, so the quotient, okay, you got another question. The quotient is the number of times it passes 0, okay? So the question is, can both the quotient and what's the relationship between the quotient and the remainder, okay? It could be both 0 if you rotate 0. So if it begin at 0, you rotate 0 clicks, then you end up with a number at 0, and you didn't pass 0, but you end up at 0, so that also count 1. So in that case, quotient is 0, remainder is 0, then you add 1, which is 1. That's correct. Now, is it possible for okay, so if the current number is 0 and you rotate 100 rotation clicks, right or left, okay, so in that case you got a 100 divided by 100, you got 1. So you got, oh, that's when the problem occur. This cannot, okay, this, okay, so I think I know what's going on. So yeah, so you see, let me show you guys, okay? So instead of this expression, so basically the quotient, so you see the quotient and remainder cannot both occur, something like that, okay? So because one example is if the current number is 0, okay, and you rotate it 100 clicks, so the new number is also 0. And did it pass 0? No. Okay, so the answer should be 1 in this case because it ends on 0. Now let's suppose you rotate 200 times. So if you rotate 200 times, then you pass 0 one time. Oh God, this is like fucking shit. Now I am out of drink. Why don't we? I think I take a break. Okay, I wanna. So we need this to remain fun. So I need to take a break. So let's be back in 5 minutes. Something. Okay, something. Almost done. Now this we don't need, and let's just cut that. Okay, 10 minutes. Hello guys, I'm back. Turn on the video. Check. Okay. What the hell is this language? This is Wolfram language, my friend. This is Wolfram language. Search for Wolfram language for programmers on xali.info. Okay. Wolfram language tutorial. Okay, you got their official tutorial and you got my tutorial there. Wolfram language tutorial xali. And there it is. Okay, so and you can download it. Okay, it's the most advanced programming language. Okay, we am back. Now the problem is I kind of know the problem. The problem is with the number 0. So if the current number is not 0, then everything, or it doesn't stop at 0, everything works fine. You just compute the quotient. Okay, the quotient. But if the current 0, the current number, the remainder is 0, then you got an issue. If the remainder is 0, then, so if it's not 0, then the result is the previous 0 count plus plus the quotient, okay, if the remainder is not 0. But if the remainder is 0, that means the current number is 0, then you need to add 1 because the current number is 0, but also you cannot, let's see the quotient. Okay, so let's see the quotient. So quotient, so 100 divided by 100 is 1. Okay, so if the current number is 5, you turn 100 clicks, you pass 0. Now, if the current number is 0, you turn 100 clicks, you do not pass 0. Okay, so there are many ways, there are several ways to compute this. One way is to check if the previous number is 0. Or alternatively, you just check the current number is 0. If the current number is 0, then you want the quotient to be minus 1. Absolute quotient, then minus 1. Okay, so basically what you want is this. Okay, quotient minus 1, then plus 1. Then it doesn't make sense. It does. Wait. Minus 1 plus 1, they cancel out. Then the whole thing is 0. That doesn't make sense. So wait, so if the current number is 0, and if you turn 100 clicks, so how does that, what is supposed to be? The current number is 0. If you do 100 clicks, then what is like the supposed answer? Well, the supposed answer is that you count it if it passed 0. So from 0 to 0, you do not pass 0. Oh God. What if the previous 0 is not 0 and the current number is 0. So if the current number is 0, there's two conditions, two situations for previous number. The previous number can be 0 or not 0. Okay, so if it is not 0, let's say, oh God. Shit. Let me think. I'll just have to think about this, okay? So when you do the clicks, whenever it's 100, it counts, except when the current number is 0. So yes, okay, so the special case is when the current number is 0. Then, yeah, the special case is when the current number is 0. That's really just the problem. The current number is 0, then okay, so you need to, this will depend on the current number. So you see the current number and the new current number, the remainder is related. You look close. I solved it in a similar way. Fantastic, user. What language did you use? So yeah, I'm pretty close. This something with the, either current number or previous number, or the 0. Okay. So I just need to clear thinking about this. So if the current number is 0, racket, nice. Okay, if the current number is 0, Okay. Yeah, this should always why can't I be just logical? Come on. Fuck. So if the remainder is 0, you add 1, right? But if the remainder is 0, the quotient needs to minus 1. Not necessarily, because okay, the special case is when current number is 0 and the remainder is 0. So you got multiple conditions. When the current number is 0 and the remainder is 0, then it should be quotient minus 1. Okay, so let me write this up. Something like, let's write it out here, okay? Minus 1. No, you can't even minus 1. Only you want to minus only if the quotient is greater than 1. What a fucking complicated shit. So when the current number is 0 and then the new current number is also 0, so what you do, you take the number of quotient, okay, the quotient. So you could minus 1 or 0 max, something like that. Complicated shit. That's right. this if expression is getting fucked up. So it's getting so let's do if the remainder so if then another if statement, okay? If the current number is 0, then okay, so I think I know what to do. Something like that, okay? Previous 0 count plus if remainder is 0, that's special case. You need to watch out. If remainder is not 0, then you simply add the quotient. That would be the number of times it passes 0, okay? But now, if the previous number, the current number, is also 0, then you need to minus 1 the quotient if it's positive. So you could say, so if the quotient is 1, it should be 0. If the quotient is 2, it should be 1. If the quotient is 0, then it's still 0, okay? So you take the max quotient, negative 1 or 0, okay? Okay, something like that. And let's just test out. Max negative 1 and 0 returns 0. That's right. Okay, so if the current number is 0, then you do that. Otherwise, just 1. Okay, otherwise, so if the previous number that, you know, the current number is not 0, but the current remainder is 0, then you just say add 1. Okay, does this make sense? This should be it. Okay. Now, Wolfram language is hard to read here. Okay, so this section is the heart. Double check one last time. If the remainder is 0, then do this. If it is not, then just add a quotient, absolute value. Very simple. But if the remainder is 0, then you check the current number is 0. If it is, then you take the max of the absolute value of the quotient minus 1, okay? But if the current number is not 0, then you simply add 1 because the remainder is 0, okay? I think that's it. It's just trial and error our way through, blast our way by trial and error, okay? So initial state, input, numbers, clear the definition of the function, define the inline documentation of the function. Because we are perfect, we document everything. Something like that. Where, so this should be new 0 count, okay? Okay, then, okay, Documentation perfect. Then here is the actual definition of this function, rotate. To rotate, it returns this new zero count and current number. Okay, and this logic, that is the logic, and this is our code. We can just remove and just fold and be back in 5 minutes. Done. Now go to Wolfram Language. Am I correct? He's struggling. User ly. Am I correct? Spoiler alert. Pasted the code. There it is. There it is. Now shift enter. Shift enter. Please, my God, please. 8 incorrect. Fuck. 8 is incorrect. Oh, Jesus. Jesus. Oh, God. I'm struggling. Did you solve the problem? Did you solve the problem? What is wrong here? Jesus. What is wrong? Why can't you just solve the problem? Where did it go wrong? Rotate init state input. No, but you also close. So you did not solve the problem? Okay, so yeah, very close for sure, but this is becoming idiotic. It's easy to solve, brute force it, but your more elegant way is a lot harder. It took me hours to solve it. Oh, really? This is like day one, number 2. It should be easy problem. It should be, annoying, the annoying advent of code problem. Actually, like usually each problem takes few hours. But they are like speed coders. They finish it in few seconds, in 10 seconds. Hello, Faye. I don't know who you are. Long time no see. Okay, I don't know what. So let's, something wrong here. Let's just think about again. If the current number is 0, if remainder is 0, if the current number is 0, then I don't know why what's wrong is it? The fuck? What the fuck is going on? What the fuck? So now the next step is to, you just need to think about this, okay? I need to think about this, like calm down and think about this. That's one way. The other way is simply start to add debugging code. So in this function, we print each step, what are the inputs, then we can visually see each step, where did things go wrong. That GPS, I don't know why it's showing username now. Oh, okay, that's bad coding. I'm doing good. GPS. Oh, okay. GPS. Well, I don't even remember GPS. Not exactly. So anyway, so this code is wrong. It's supposed to be 6. And why are we, so 0, 690. Did we miss some special case? If the current number is equals to 0. Oh, so I think this is not just -1. This should be absolutely 0. That's right. Wait. If the current if the current number is 0, and if you do 200 ticks, how many would that count? 2, right? Okay, I think this 0, I think that's it. Okay, I think that's it. Select all, paste, 5. Now it's 1 less. Shit. Max absolute value. So if you have 200 clicks and current 0 is 1, so you passed so you passed it. You pass it 1 time, but also it ends on 0. So what is the situation? You pass it 1 time, but also ends on 0. Return to day 1. Point at 0. You see, none of these give a situation when the turn is exactly multiple of 100. So you got several cases where it ends at 0. The current number is 0, but there's no instance where you rotate 100 or 200 or 300 clicks. So, but suppose the current number is at 0. Okay, you count it from, you count that as an occurrence. Now you do rotate 200 clicks to the right, let's suppose. So 200 clicks, you will end up on 0 again. Okay? But meanwhile, did you pass 0? Yes, you pass it once. However, the quotient of 200 is 2. That's why now is this -1 correct? So if the click is 300, So you end up on 0, but you also pass 0 one time. So, so what is the what are you supposed to do with that situation? The number of times the dial is left pointing at 0. Wait, that's problem 1. The problem 1, the password method 0x something. Remember from the training seminar, means you are actually supposed to count the number of times any click causes the dial to point at 0. Okay? Regardless of whether it happens during a rotation or at end of one. So if you start at 0 and if you do 200 clicks, now the proper answer should be 2. That's right. So I think, our model of the problem could be made, use a different model that fits this better. Right now we are doing, but it's still modular arithmetics. But there's something wrong here, okay? So again, if the beginning number is 0, you turn 200 clicks, it ends up at 0 again. But meanwhile, it passed 0 once. So in this rotation, then you would add 2 counts, 2 occurrence, okay? So did we catch that situation? So this quotient is 2, 2 minus 1. That's correct. 200 divided by 100, the quotient is 2. 2 minus 1 is 1. Okay, that's not correct. The quotient we always add. I think our model is like, is it completely wrong? This absolute quotient. Oh, our model is completely wrong. Fuck it. Because it's not absolute quotient. Our model is incorrect because this is quotient. Because for example, this simple example, current number is 5. You turn left 1, 2, 3, 4, 5, 6 times, and you will get 1. Oh, we're missing. We're missing something here. Quotient, remember, current number plus rotate n plus 100. Okay, something like that. But hold on a second. You see, if you have 5, then you rotate 1, 2, 3, 4, 5, 6 times left, minus 6. You get 99. However, you did pass 0. So result is 199. Okay. And according to our previous test Did we test that case? We did. Open it. You see 5 and you rotate left 6 times, you get 1 passing 0. Wait, how did that? So this is 5 divided by -6. So the negative passed on to the rotation. That is incorrect. Because if you do this way, anytime you have a negative, you're gonna incur. So let's test that, okay? Our model is just wrong, okay? Now if your model is completely wrong, you idiot. Okay, so for example, if you 5 and turn left 4 times, okay, so you have 5 and so you got 5. Let's open this. Yeah. So you got 5, then you turn it to the left 4 times. 1, 2, 3, 4. You arrive at 1. Did you pass 0? No. So this, if you run it, what? Wait. Run it. Oh, undefined. Well, okay, you need to run the whole thing. So you run it, you got that, which is correct actually. So our model is here is correct. No, it's not correct because God. Current number and rotate n. So rotate right plus rotate left. So when does it pass 0? So this not right? 50. So if it's 50, oh, there is a problem. 50, 50. Yeah, this is not good. Wait. So if you are at 50, you rotate right 50. Pretty bad. Yeah, so this may not be right. So current number, it's passing 0, so 0 goes to increase to the left. So rotate right means plus, rotate left means negative. Okay, so whenever you have a number, can the number be negative? Not really. So whenever you have a number, go to 99. 0 to 99. Rotate right means rotate right means what? The number increases to the right. Rotate right means minus. Did we get minus and plus sign wrong? Fucking shit. Rotate, yeah, we got minus and plus sign wrong from the input. Oh god, fuck it. The input minus plus sign is incorrect. Okay, so that's what are we dealing with? You know, the right left is got wrong. That's why. Okay, let's just do it one more time. Okay, so show in browser. So this, let's, so what is this one? Day 1 problem 2. That's today. Voice check, video check. Okay, so we got the input may be incorrect. Search for initial state. Okay, so wait, so let's see this one. Okay, don't ruin that one. And this one, okay, that's the model. Then next, so this one, the inputs, we got the sign reversed, maybe. Let's check. LLR. Now L actually means positive. Okay, so we got it, the sign incorrect. What the fucking shit? So L is actually positive. Now let's check yesterday's code. Yesterday's code, did we do it correctly? L, oh, yesterday we just do rotate left. Okay, it's simple. But now we're doing modular arithmetics, so we got the input wrong. How can it possibly be? Fuck. So so let's get the input again. Is that the input? Yesterday we have, yesterday, here is the input. Okay, so the input, okay, let's do it here. So the input L is actually positive. First of all, remove the quote. Okay, now L is positive, so capital L removed by nothing. Now R become negative. Okay, so that is bad input. Now that is correct input. Now if we, is our logic still correct? Not sure. So let's copy it. Let's just run it. So Wolfram Language here, select, paste, shift enter. You got a syntax error quotient. Okay, you got the syntax here. Okay, copy all, select all, paste, shift enter. 4. Okay, something is wrong. Now how incredible, we got the input incorrect, sign reversed. Very painful. Okay, let's make sure. Rotate left. Wait, rotate left actually means wait, rotate left means decrease. Oh god, what am I thinking? L, rotate left means decrease. That is correct. What am I thinking? I subtracted on the right. Okay, I subtract on left, added on right. Yeah, so You are correct, but I think right now I'm totally screwed here. It's like um so left is negative. Okay, left. So why is our code incorrect? So this should be quotient. Fucking idiot. It's right. Why is this not good? Why is this not 6? There. Okay. Found it. This should be 1. Yeah, it's fucking stupid. Okay. Copy all. Select all. Paste. Eval. Now it's 8. What the heck? Zero, zero, 0. 99, 0. The logic is wrong somewhere. So, wait. So, 5, then the current number is 0. So, the current number is 0. Then it adds 99, 6. So between these two, why did it become 92? Okay. Previous 0 count plus if remainder is 0. So if the remainder is 0, stupid. Shouldn't you have one here? I think so. Okay, maybe this time, please, God, please. No, I become 12. It has to move 100. That's why I got 8. You're probably counting 0 because starting at 0. Mm-hmm. Mm-hmm. This is a annoying name. Let's change it. Okay. I think. Okay. Mm-hmm. Trial and error. Copy or paste it, evaluate it. 6 correct answer. You see? Correct. Now let's try our custom code. Okay, now this long list of code. Now we just need to get our code. Okay, this long list of code. Let's see. Copy it. Okay, here, and here is our new code. Okay, let's delete the old code. Delete. Okay, the new code, the init state, input, delete. Init state, move to the top. Same. Init state, custom input. Now custom input is 20. 20 is right. R20, R10. Okay, let's check. R20, R10. That's right. Right is positive, left is negative. Okay, so that, and new code, copy, go here, select all, paste, run it. Okay, 6580. That's the same number I used before, and it says it's incorrect. Let's try again. Paste 6580, submit. That's not the right answer. Okay. So now we need to examine our existence. I don't know. I think maybe I'll stop. Let's just say we failed today. And we're gonna do tomorrow. And this is not good because this simple problem shouldn't take that long. I am very annoyed by this simple problem. Very annoyed. So we really need to think about this rotation business. I think our model here is even incorrect. This part may not be right. Because over here we are kind of relying on negative numbers to get the quotient. I think it might be incorrect. I don't know. But over here, R20. Did we get the R and L correct? The input must be. Okay. So here's what we do. Okay. We're gonna continue this maybe until it's done. Okay. Okay. It's like code or die. I'm gonna complete this. Okay, be back in 10 minutes. I'm back, guys. Pesky problem. Now let's have some Ricola. Can you see? This is candy, Ricola. Can you see? Ricola. This is throat candy, so I don't cough so much. UXK keyboard, fantastic. It'll make me a great programmer. Back to code. Now this, we just have to carefully go through this, okay? So, it's interesting you're still watching. Wow. Said. Who is the guy who asked me what language I'm using? Is that you? Who is it? Ask me what programming language I'm using. Did he delete the comments? Oh, what the hell is the language? Jose says. Okay. Okay. So the problem, so let's go back to our drawing board. Okay. So this operation, let's check this part. What? Okay. Does this always work correctly? rotate left. Wait, so rotate left -4. Oh god, we got the sign wrong again. What the fuck is with the sign? So if negative means rotate left, wait, right, left, okay, 4, 1, 2, 3, 4, that result is 1, so okay. So if you rotate right, 5, 1, 2, 1, 2, 3, 4, 5 is 10. That's correct. Rotate left negative. Rotate left 5. 1, 2, 3, 4, 5 means 0. Okay, let's deal with negative first. So let's move the positive down. Okay, 1, 2, 4, 5, 6. What if you have rotate left 99? Okay, 0, 0, 0, 1, 0, 0, -1, 99. Then this is -1, 6. So rotate left. So 5, rotate left 4, you got 1. Rotate left 5, you got 0. Rotate left 6, you got 99. Now rotate left 100, you got 5 again. Now, but rotate left 99, you got 6. That's correct. So the rotate left and so rotate left 99, you pass 0, okay, 1 time. So once you go beyond 5, you pass 0. So you got 1 there, 1 there. Should be correct. Now rotate left 200, 101, 606 should be right, okay? This operation, this function should be correct. Is it correct? Make sure one more time, because this is fundamental. Okay. I'm probably doing shit, so I don't know if you guys want to continue to watch. So now, right now, I'm not in my best mind. So anyway, so this function, is it correct? Operation, X operation, current number, rotate n, returns a list DC. So we can improve the documentation. Yeah, let's not. Okay. D is a new index number. Okay. Is this operation correct? Can we be certain? Looks like. Now, what if you say rotate 0? Will it do anything wrong? Oh, you need to evaluate the whole thing. Okay. Rotate 0 means it didn't pass 0 times. And the result is still 5, so that's also correct. Is this operation reliable? Are you sure? Yes. Current number plus rotate n. Yes. And current number is always a positive number. Is that right? Yes. So this number, this algorithm, this function, let's say it is 100% correct. We can trust it. Okay, this operation. Now we back to our problem. Why is our problem? Why can't we solve this problem? Fuck. L68, L30, 6830. Then L is negative, right? L is negative, okay? R is positive. That's right, because the number goes counterclockwise. Okay. Wait, are you sure? Because it shows some examples previously. Where is it? Yeah, it kind of showed the example. Okay. So we can remove this input. L is negative. L is negative. R is positive. Okay. Right. Now, so now we back to this this problem. Why is our code incorrect? Okay. First of all, the number of times it passed 0 is given in this question. Wait, hold on. Wait, the number of times it passed 0, did we cover that before? So, oh, we didn't. Wait, hold on a second. So, hold on. Before we do this, let's revisit this previous. What if you begin with 0? That is the problem. And you rotate, let's say 5 times. Run it. Okay, that means you arrive at the number 5 and no pass. Okay, but now you begin at 0 and you rotate 100 times. 100 clicks. Do it. There lies the problem. It says you pass it 1 time. So when the current number is 0, there's a special case. Wait, the current number is 0. You rotate 100 times. Oh, God. Let's try negative. Would it? also give something. It'll just be -1. Yeah. Okay. And let's say if it's 101, what if it's 101? Run it. What? 0, 5, 1, 0, and 1, 1. That's right. That's the result. Okay. But the problem is here. So if it's 0, it begins with at 0. You rotate it 100 clicks. It returns 1. However, you did not pass 0. You merely stop at 0. So this is a bit tricky. Okay. Okay, so yeah, so when it's 100, when it's 0 and you do 100 clicks, zero zero will work for sure. It'll just return 0. You see? Because you are just doing the remainder. Okay. The tricky part is this. Okay, because this indicates the documentation is incorrect. Because if you begin at 0 and you do 100 clicks rotation, did it pass 0? Not really. But it began at 0 and stopped at 0. But however, it returned, 1. So the tricky part is the meaning of passing 0 and stopping at 0. Is there a way to reconciliate them so that the algorithm becomes very simple? If you look at this example, starting at 0 and 100 clicks, that means start at 0 and after 100 clicks, it ends at 0. So even though it doesn't pass 0, but however, it ends at 0. So by the requirement of the problem, the result is still 1 because either passed or ends at. So you might say this operation is simplified, nothing special. But however, it doesn't work when you have this case, for example, starting at 5 and move to the left 5 clicks. So in this example, you didn't pass 0 and you end at 0, but however, the result should be 1 because you ended at 0. So there is two cases in kind of in different in and both of them are basically related to either beginning at 0 and end at 0. So or this ends at 0. So another way we could say this is simply wrong because it didn't pass 0. It just ends at 0. Okay. So we can add a special case here when if the current number is 0 and end at 0, we must minus 1. When the current number is 0 and end at 0, then we must minus 1 to mean the number of times it passed 0. But at the end, we have to add 1 again because it ends at 0, okay? So this function is actually technically incorrect. The number C returned is not the number of times when it passed 0. It is wrong in a case when you begin at 0 and also end at 0. But if you begin at 0 and but you don't end at 0, then it's still correct. So let's see, you begin at 0 and not end at 0. Is there any case like that? Yeah. So anyway, so this function is technically incorrect. It is incorrect when you begin at 0 and when you end also at 0. In that case, you need to subtract 1 from the first element. Okay, that's the current analysis. So this is technically wrong. Let's write it out, okay? For this, since we already spent like 2 hours, 3 hours on this. This function is incorrect when current number is 0 and the result is the result second part. Let's say the result index number is also 0. In this case, the returned value first part should minus 1, something like that, okay? Something like that, okay? Now put it back. I'll go to the next. Okay, now next. Now, so we are computing it's all correct. Like normally you would say, normally the result would be previous count plus previous count plus, if the remainder is equals to 0, add 1, else 0, okay? That is, if it stops at 0, add 1, else don't add. Okay, normally that should be the result, but we do know this operation is incorrect when it begins at 0 and end at 0. So what we have, we have logic to counter that. So when the remainder is equals to 0, okay, if the remainder is not equals to 0, then just wait, what are we doing? Wait, previous count plus absolute, okay, plus absolute quotient plus, so this is the normal. This is the normal result. Previous zero count plus the absolute of the quotient plus the remainder is if it's 0, add 1. Okay, this is the number of zero count or ended at 0. And then remainder, the current number, okay? Now, but because this quotient operation is incorrect when the number is at 0 and also end at 0, so we need to like do a correction. So if the remainder is 0, if it's not, then whatever the absolute quotient, if the remainder is 0 and also the previous number is 0, then the absolute value quotient needs to minus 1. Did we get the max wrong? Shit. Absolute quotient minus 1. Absolute value of the quotient. Did we get this part right? The more logical way to say this is if that absolute value of quotient is greater than 0, then greater than 0, then that minus 1. Okay, otherwise just 0. So otherwise just absolute value of the quotient, okay? Because it's not greater than 0, so it's either equal to absolute, always is it's 0 or greater than 0 when you have absolute value, right? So it's, so do you guys know what I'm saying? Guess not. So absolute quotient, if it's greater than 0, then minus 1. Okay, but I think this should be equivalent to that. Maximum of between that minus 1. So let's say if the quotient is 1, 1 is greater than 0, true, then quotient minus 1, it becomes 0. Okay, so 1, 0. So 1, if it's 1, it's 0. If it's 2, it should be 1. If it's 3, it should be 2. So it should be whatever it's, it should be 0 or the minus 1. That's correct. So I think that's correct. Otherwise, absolute value quotients. So the only situation you want to minus 1 is both the remainder and previous number are 0. Now, what if the remainder and previous number are the same? Oh, that's another situation. Fact, yes. Let's say, did we? Let's say this case. The new number is 5, the previous number is 5. Okay, if you turn it multiple times, 600. 1, so 1, 2, 3, 4, 5, 6. That should be correct. Now, I don't understand why is my algorithm incorrect though. Fold initial state input. Okay. Should plus 1 though. What? What am I doing? What am I doing? Special case only happens is 0, okay? Special case only happens when it's 0. I thought we documented. Refresh. What? No, we didn't. What? Let's put it back. What? This function is incorrect when current number is 0 and the result index is also 0, okay? It's only incorrect when current number is 0 and result is also 0. So now if we go here, -1. That looks correct. Okay. See, this looks correct, but I'm going crazy. And see, I'm going crazy over here. Can it be this? No. Let's try equal. Yeah, no. Just incorrect. Okay, something is incorrect. So 60. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 rotational operations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, so 10 operations beginning with the initial condition, okay? So you can kind of see 1, 2, 3, 4. So 1, 2, 3. On the third operation, can we edit it? 1, 2, 3. Third operation, 48. So 1, 2, 3. On the third operation, 48 plus 48, you got 0. So on the third operation, initial 50. 1, 2, 3. Third operation of R48, you arrive at 0. That's right. By then you already rotated how many times? Let's see. The dial. Okay, so the initial condition. So there's 1. There's first operation 1. L68 arrive at 82. L60 arrive at 82. 1 rotation, passing 0, correct. Then second operation, L30 arrive at 52. Okay, still 1 time occurrence. Then the third operation, dial is rotated R48 and arriving at point 0. So the third operation, R48, this one, here, arriving at 0. And all of a sudden, we got 3. So that's fucked up. L30, R48. So 52 plus 48. So hold on a second. So we got 52 and 48. So what is going on? So can we still call our function? Yes. Let's open a new one. Okay. And start to massive. So we have previously 52, then 48. Okay. 52, then plus 48. Okay, so at 52, then you rotate right 48, you arrive at 0 again. And did you pass 0? Yes, but somehow you got 3 here. So there is something in your logic here is incorrect. So something in our logic here. So if the remainder is 0, oh, previous count. Okay, so let's just not add that. New, paste, run it. Now this one is correct, okay? Let's copy that. Paste the intermediate result and let's magnify. Okay, so now Now this answer is correct for the toy example input. Okay, so that's initial 050, then after 3 operations, it's after the 48 you get 0, so you get a 0, and at that point you have 2 times either passing 0 or end at 0. Is that right? So 1 time, 2 time, that's right. So L5 95, so that's L5 2.95, so this is incorrect. 595, why is it increased to 3? So our algorithm is like fucked. What? Which one are we looking at? Close this one. Okay. 395. It's not 3. So from this 20, it becomes 3. So 0, 0 minus 5. 0 minus 5, which is minus minus 5 is rotate left. Rotate left. So you got 95. Okay. 0 rotate left 5. You got 95. So, but why do you get 3 here? The remainder is not 0. In the quotient, the previous count. So why do you get that? Did we? God, need to print something. Okay. This is print debug. Starting to print debug. Just print the fuck out of it. Just print one bunch of numbers so that we may better debug it. You know, there's no way, because computer don't make mistake unless my CPU is doing some magic trick of bits. Otherwise, something I did wrong. Okay, so now it's like better. You just need to okay, copy, and let's do the full list. So we are starting to do heavy debugging. This I don't know what the fuck is going on. Previous count is 0. Previous number, previous 0 count 0, 50. So between, so the problem occurs when, oh my god, every time this runs, this got the long thing, shit. Can we actually make this long line? Shift enter. Yeah. The problem is this increase, okay? So the problem is here. This is initial step, first step, second step, third operation. Then the fourth operation, that first number is incorrect. We want to know why. Okay, so we have the steps here. Previous occur is 0 number, previous number is 50, 0, 50. Okay, then 182. Then 182. Wait, the quotient. Okay, 50. Then the result is 182. Okay, then 152 here. Okay, then 20. Okay, previous 0 count is 2, previous number is 0. Okay, now be careful. Now how did it become 3? Now previous quotient, x quotient is -1, so x remainder is 95. So 20 and 20 and 395. Wait. What? L295. Yeah, where does the 395 come from? Where does the 3 come from? So before the count is 2 and previous number is 0. Then you do the step 2 0. Okay, 2 0. So the fourth step is L5. So 0 L5 minus 5 is 95. Okay. There's a problem. There is a problem. Starting at 0, you don't end with 0, but you still have a problem. Because when it's 0, so we found a bug, finally. When it's 0, initial condition, and you move -5, okay, so that's why I think our thing here is incorrect. Our thing where this operation got two problems. Okay, so next stop is to fix this operation. Okay, so next stop is to fix this operation. We kind of found the problem. Kind of very annoying. Okay, hold on a second. So let's clean up this thing. I think I gotta go pretty soon. It's not. Hello guys, I'm back. This is not going well. This is like 3 hours, or was it 4 hours already? So let me turn on my camera. I gotta go. My wife coming back soon. Whoa, long stream. Just got back from gym and had dinner. Fantastic. Avindra. So long session. We got stuck in a bug, and I have found the bug. I think I gotta go. Yeah, my wife is back. Hold on a second. I think I gotta go. Terrible session. So I gotta go. And we found a bug. The bug is presumptuousness. Because we found the bug is this operation is incorrect on two accounts. An hour ago, we identified one of the problem, but now we know another problem. So this is just too fast coding, kind of too fast coding. That's why we didn't think thoroughly. That's why there's a bug. And I can continue, but yeah, but it's probably not good. So let me just do another video, then continue this next time. Okay, bye guys. Thank you guys for hanging around. Yeah, I'll get it soon, I hope, for certain. Bye guys.